Today we're going to talk about proving lines parallel. So we want you to learn to use the transversal in proving lines parallel and to be able to relate parallel and perpendicular lines to each other. So first of all, let's talk about postulate 3-2. And this says that the converse, this is talking about the converse of the corresponding angles postulate. Now if we recall the corresponding angles postulate, it said that if a transversal intersects two parallel lines, then the corresponding angles are congruent. The converse would be of that, if two lines in a transversal form corresponding angles that are congruent, then the two lines are parallel. So in the first postulate, we're given two parallel lines and as our hypothesis, and then the then, or our conclusion, is that the corresponding angles are congruent. Of course, the converse of that flips that around, so instead our hypothesis is that if we're given two lines in a transversal that form corresponding angles that are congruent, so that's our hypothesis, then the two lines are parallel. Okay, so we have line A here, line B here, and a transversal T, right? We have corresponding angles, maybe we could call them angle 1 and angle 2, right? And so if we're given that we have two lines in a transversal and that angle 1 and angle 2 are corresponding angles, then line A is parallel to line B. And so this is the postulate that we use when we are looking to prove that two lines are parallel. To do that, we need two corresponding angles in this configuration. Okay? Next, we want to talk about theorem 3-3. This is the converse of the alternate interior angles postulate. And so again, this flips around our hypothesis and our conclusion and allows us to, instead of showing that interior angles are congruent, we're able to show that two lines are parallel. So if we are given two lines and a transversal that form interior angles that are congruent, then we can show that our two lines are parallel. So again, if we have line A, line B, transversal T, and we have interior angles, alternate interior angles that are congruent, so angle 1 and angle 2. So if we know that angle 1 is congruent to angle 2, and we've got these two lines in a transversal, then we know that A is parallel to B. So again, using the converse of these, and we'll prove that these converses are true, which give us a true biconditional in the sense of the alternate interior angle scenario, then we can show that parallel lines are two lines are parallel. Sorry. So this is a second way to show that lines are parallel. A third way is the converse of the same side interior angles postulate. And this says, again, switching that same side interior angles postulate, if we have two lines in a transversal that form same side interior angles that are supplementary is what that word should say. I've got to get a new stylus because it's dragging on my screensaver. Then the two lines are parallel. So if we have line A, line B, transversal T, angles 1 and 2 here, if we know that the measure of angle 1 plus the measure of angle 2 equals 180, and we've got two lines in a transversal in this configuration, then we can prove that line A is parallel to line B. So this is a third way that we can show lines are parallel, which is why this section is called Proving Lines Parallel. We've got three different ways so far that we can show that and actually prove that two lines. So here's a third way actually. Theorem 3-5 says, if we have two lines that are parallel to the same line, then they are parallel to each other. So if I know that A is parallel to B, and B is parallel to C, notice I'm using my angles to show parallel, then I know that A is parallel to C. Okay? So this is our transitive property at work here. So if A is parallel to B, B is parallel to C, then A is parallel to C. Yay, transitive property. And finally, the 1, 2, 3, 4, 5th way, we've got to show that two lines are parallel to each other. This says, this is theorem 3-6, it says in a plane, very important, in a single plane, if two lines are perpendicular to the same line, then they are parallel to each other. So we have here line A, line B, and our transversal here. So if A is perpendicular to T and B is perpendicular to T, then A is parallel to B, and that's what this says. Okay? So we are able to show that in one single plane, okay, if two lines are perpendicular to the same line, then they are parallel to each other. So, not quite the transitive property, but it kind of has the same feel as a transitive property in theorem 3-5. Okay? So we will go through some problems that relate these postulates to each other and to different scenarios in our assignment, and hopefully that will be something that helps you really internalize what these postulates are saying. Because I really don't care if you memorize the specific names of the postulates, but just know what they do. And if you know what they do, you'll know the names of them.